Acids react with sodium to give hydrogen gas, one of the products. A student thought that the volume of hydrogen given off could be used to identify the alcohol, blah, 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 blah. So first of all, the reaction is exothermic, suggests how the reaction mixture could have been maintained at close to room temperature. You use an ice bath or a cold water bath. Use the figures to calculate the relative molecular mass of the alcohol. Now you might ask why I'm talking about this particular one here. Quite simply because, of course, this is actually a oxidation reduction reaction. The sodium goes from 0 to +1, so it's oxidized. The hydrogen goes from +1 to 0, so it is reduced. And it's always a good idea to keep in mind all of the little calculations that you are supposed to know how to do. So, molar volume, that's a nice A-level concept, at 298 Kelvin, 1 atmosphere pressure, which is what we got, 298 Kelvin, 1 atmosphere pressure, 24.5 cubic decimeters per mole. So therefore we have 0.184 cubic decimeters, so we'll divide that by the 24.5 cubic decimeters per mole, giving us 0.00751 moles. So in other words, 0.00751 moles of our hydrogen is made by the alcohol, but we need 2 alcohols to give us 1 hydrogen. So the moles of alcohol is 0.00751 moles times 2, which is 0.015 moles. And then we have 0.9 grams of the alcohol is in that 0.015 moles for the molar mass in grams per mole. Just divide the grams by the number of moles, and you get about 60 grams per mole. Still on the same question, the alcohol used gave a ketone on oxidation. Give the displayed formula of the alcohol. Well, we know from previous part, molar mass is 60 grams per mole. If when we oxidize an alcohol we get a ketone, that tells us that the original alcohol was a secondary alcohol. In other words, contains this group, carbon to OH to H, with 2 other hydrocarbon groups, one this side, one that side. Whole mass here is equal to 30. Which means that these 2 groups, this one and this one, together must weigh 60 minus 30, or 30. And the only way you can get 30 out of having 2 groups here is for them both to be methyl groups. So there is our answer. Propan-2-ol or isopropyl alcohol, depending upon how old you are. Question 14, octane 2,3-dione is a pale liquid. Octane 2,3-diol is a colorless material. Suggest a reagent that can be used to produce octane 2,3-diol from octane 2,3-dione. Well, there's the octane, 1, 2, 3, 4, 5, 6, 7, 8, 2,3-dione. And there is the octane 2,3-diol. Going from a ketone to a secondary alcohol is a reduction. And you can use either of your reducing agents, NaBH4 or LiAlH4, aqueous solution, and hydrous conditions. How could you study the rate of reaction in part 1? Well, you're starting with a yellow, you're ending up with a colorless, so therefore you can just follow it using a colorimeter or a spectrophotometer, depending upon how much money your school has. And finally, oct-1-ene-3-ol formed biochemically by the breakdown of linoleic acid. There's linoleic acid. Carbon-to-carbon double bonds are reduced by hydrogen. The resulting product can then be reduced by another suitable reducing agent to give a compound of formula C18H38O. Okay, so what's the skeletal structure of this compound? Wow. Well, there is our linoleic acid. The first thing we're doing is we're replacing all the double bonds by hydrogen, so just hydrogen with a suitable metal catalyst, giving us that. And now we're going to do another reduction. Well, what else can we reduce? We're going to be reducing the acid group, okay? And so when we reduce an acid group, we can either make the aldehyde or we can make the alcohol. So there's the acid going to the aldehyde, there's the acid going to the alcohol. Now the aldehyde has got a formula, if you count it all up, C18H36O, and the alcohol is C18H38O, thus it is the alcohol that we have made. And there is the skeletal structure thereof, making sure we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons. I'm glad that worked out, actually. And what's the name of the reducing agent used in the second stage of the reduction? Well, that's going from an acid to an alcohol, but anytime you want to reduce an acid, you have to use the stronger one, lithium aluminium hydride, AlIAL. Don't know why I can't say that properly, LiAlH4, and of course in anhydrous conditions.